Greetings all, this is meant to be a very quick introduction into non-parametric tests from fields, discovering statistics with R. This is chapter 15. So the first thing we're going to do is have my cat show up, is we're going to load in the data that we want for our file. And that's, in this case, I'm going to call drug data, though it could be named many things. It doesn't really matter what you name it. So what I just did there was to say let me choose, and you can't see the box, but just open up a simple file for me to choose which one, what file we're using right now. And this first set of data is the drug.dat. So I just opened drug.dat, which is found in field data in the folders. Anyways, if you type drug data here, you'll be able to see the data that we just loaded. If nothing shows up there, an error shows up, you didn't do it right. So now that we have our data in the world, we may want to run some descriptive statistics on it just to get an idea of kind of what the data says. It's always a good idea to run descriptives first. The descriptive the descriptive function I'm going to use requires the library name PastX, so I'm going to tell it to install PastX. Now, I already have it installed, so it comes up and says it's not going to install it again, but you probably don't, so I wanted you to see that. After I've installed it, I load it. To be clear, you do that every time. So now that I have PastX installed, I can drop a relatively nasty looking function into the world, which I'll talk about shortly. So this says going through our data file, which is drug data, and look at the second and the third column, which is Sunday BDI and Wednesday BDI. Then please describe, make it not a basic analysis, and give us information about normality. That drops out both of these. Now what the by did was tell us, hey, do alcohol and do ecstasy. That's really what that's doing for us. So looking through these, really the place that we're going to look for first are these norm tests. And the p-value on this norm test is less than 0.05. Violates the assumption of normality, which means you should be using a non-parametric test. Probably. This one here also violates the assumption of normality. So we have two assumptions of normality violated. That tells us being non-parametric tests, which is the title of this chapter, non-parametric tests. Alright, so having done that, the next way we can test this is to use Levine's test for normality, and that's in the car library. So just like we did before, you would install the package car. I'm just going to put it in as a comment this time rather than running it. Without the pound sign there, that would have installed the package for you. I already have it installed, so I'm not doing it again. Anyway, running the Levine test for these two sets of data. First Levine test here gives me a p-value of 0.07. That's not significant. Second Levine test gives me a p-value of 0.48, also not significant. So in my exploration by drug, we were able to get significant values, whereas when we clumped them both together and just looked at the variance, it wasn't significant. That's why it's a better idea to run an analysis using this, where you break it down by the groups that you're looking at. There's more to be said about that, but I'm not going to right now. Okay. Now that it's done, we actually get to create our models, which is the whole point of a Wilcox test. So this is creating a model named Sun Model for Sunday Model. It is going to be using the Wilcox test, and what this says is your depression index on Sunday by the drug you're using, and our data is drug data. So we have basically the question, was the depression level different between the alcohol users and the ecstasy users on Sunday, is what this would answer. And it comes up with a nice little error for us that says, oh no, can't calculate. Now, even though it says that, when we run the Sun model, we get a p-value of 0.28. Okay, I'm going to go put that correction in. Okay, so it doesn't throw the error anymore. But you'll notice if you just looked between these two, we have the same number. So it kind of automatically goes, you didn't pick the right one. You didn't tell me exact, you had ties. Exact should be false with ties, so I'm just going to make it exact. And it gives you the right answer, even though it complained. Here we hard told it exact is false, and it gave me the same answer it did before. Either way, p-value 0.286, there isn't enough evidence to say that the Sunday depression differs by drug. Okay, we're going to do the same thing for the Wednesday model. And there is absolute evidence to say that the depression level differs by drug on Wednesday. Note, that doesn't tell us which one's higher yet. We'd need to do something in order to find out what those averages were. So, we can come back up here and say, alright, in ecstasy land, my average Wednesday depression level is 32. In alcohol land, my average Wednesday depression was a 10. Okay, so depression is very different for ecstasy people than it is alcohol people. I believe the way this scale was set up, a higher level of depression is a higher number, so we could say that the ecstasy users were more depressed on Wednesday than the alcohol users were. Alright, now that we've done that, that's the end of the ranked sum test. To go back and just quickly talk about that, this test would be used if you have exactly two groups, in this case alcohol and ecstasy, and you're asking if they differ based off of some interval or ratio data, in this case our depression index. The experiment we're handling here basically is that a scientisty guy went into a club and tested the depression levels of ecstasy users and alcohol users on Sunday, and then went back to the same club, not back to the same club, took the same people and tested their depression levels on Wednesday. So started on Sunday, got levels baseline, and then again on Wednesday. And maybe it was Saturday and they tested the depression the day after. It doesn't really matter. 2 different days of depression. That's what we're looking at. Alright. We're going to move on to... No, I'm not. That's the end of that test.